Linear inequalities in two variables. Graphing linear inequalities involving less than or equal or greater than or equal. A linear inequality in two variables can be written in one of the following forms. Ax plus by is less than c, or ax plus by is less than or equal to c. Or you can have the greater than version. Essentially, that's like standard form of a linear function. Remember, we have slope-intercept form, standard form, point-slope form, and so this is just one of the formats. And it says a, b, and c are constants. They're just numbers. And then it says, but they can't have both of them be 0, because you want one variable in there, so that way you have something to graph. The solution of an inequality in two variables is one or more ordered pairs that can make the inequality true. So with a line, we talk about points on the line that make it true. But with an inequality, it can be points either on the line or above or below the line, whether it's greater than or less than. It says some students at a music recital perform 3-minute pieces, and some perform 5-minute pieces. The total time of this part of the recital needs to be at least 30 minutes long. An inequality that represents this is 3x plus 5y is greater than or equal to 30. The 3x, that represents the time for the 3-minute pieces. The 5x represents the time for all of the 5-minute pieces. And we have at least 30 minutes, so it has to be more than or equal to 30. Then in part A, it asks us to solve the inequality for y. Essentially, we're going to change it from standard form into slope-intercept form. So we have 3x plus 5y is greater than or equal to 30. To get it into slope-intercept form, we're going to move the 3x over. This is eliminated from that side, but we still have 5y. And then 30 and negative 3x. We can't combine those because they're not the same type of piece. So we just write them next to each other. Then we're going to divide both sides by 5 to solve for y. And 30 divided by 5 is 6. In B, it says, replace the inequality symbol in the inequality with an equal sign. The inequality is now an equation that will be used to graph the line. The line is called the boundary line of the solution set of the inequality. Write the equation of the line. So we just swapped out the inequality with an equal sign. So now it's easy to identify, okay, this is our y-intercept and this piece is our slope. Over here in C, it says graph the boundary line. So we're now going to start at the intercept. And keep in mind that it is counting by 2's on the axes. So make sure when you go down 3, you're going down 3 and not just down 3 boxes. And it says it uses the greater than or equal to symbol, so the line will be solid. Just like when we were graphing inequalities on a number line, if it had that equal to symbol, we used a solid dot. And it says to show the points of the boundary line are in the solution set. So starting at 6, going down 3 and over 5, down 3 and over 5. Then we're going to make it a solid line. D says the part of the coordinate plane containing the solution set to the inequality, which may include a line, is called a half plane. Since the inequality symbol is greater than or equal to, 2 conditions must be met. First, the boundary line must be solid, which we already did, based on the equal to piece. And the half plane above the boundary line is shaded. Shade the appropriate part of the graph. So what it's asking us for is to shade above the line because it is greater than. So we're going to shade above the line. It's asking us to check the solution by filling in the table. So that point 0, 0, if we look at the graph from part D, is 0, 0 above or below the line? And then how about 8, 8? So then we're going to plug it in to the original inequality we were given, and we're going to find out if these are true or false. Well, 3 times 0 is 0, and 5 times 0 is 0. So 0 plus 0 is 0. And is 0 greater than or equal to 30? No, that is false. 3 times 8 is 24. 5 times 8 is 40. Is that greater than or equal to 30? Well, yeah, that would be 64. 64 is bigger than 30. How would the graph change if the inequality were greater than instead of greater than or equal? Just like when we were graphing on a number line. If we had a point without the equal to symbol on it, we would use an open circle. So on these graphs, we would use what's called a dashed line. It's like the open circle version. We're going to use a dashed line instead of a solid line. This says, graph the solution set for the given inequality using the method given. Graph 21 minus 3y is less than 9x using a graphing calculator. Well, your graphing calculator wants everything in the format of slope-intercept form, where it's solved for y. So it says solve the inequality for y. So you can see they start by moving the 21 over to the other side by subtracting, and then they divide by -3 on both sides. Remember, when you divide or multiply a negative in an inequality situation, you have to flip the symbol to the other side. So it changed from a less than to a greater than symbol. Then it says enter the equation into y1 on the graphing calculator. If you're using one of those apps I recommend, or the TI-84 from Texas Instruments, the y equals button is that top left button on the calculator. And it's going to pull up that window like you see on the right. And it says enter the equation. So you're going to enter that in the top line of the y1 section. If you are trying to get the variable x, it's right next to the alpha button on the left side. If you're using the actual calculator, it says go to the far left and hit enter 2 times until it looks like this. But if you're using the app, you can go push the arrow keys all the way over, hit enter, and it's going to pop up with a little toolbox. And you're going to change the line style so that it has the inequality symbol that matches the one on there, that little shaded triangle. Now view the graph. Note that the calculator will draw a solid line. Determine whether the line should be solid or not. So you're going to hit the graph button on the top right, and it's going to show you the shaded graph. Now, looking at the original inequality, back up here, should the line be solid? No. It does not have less than or equal to or greater than or equal to. There's no equal to in it. The line should be dashed. B, graph -14 plus 2y is less than -x by hand. Solve the inequality for y. They start by moving the 14 to the other side, and then they are going to divide by 2. So that gives us -1/2 x, and 14 divided by 2 would be 7. Graph the boundary line. The inequality uses the less than symbol, so we use a solid or dashed line. It doesn't have the line underneath, so it should be dashed. And show that the points on the line are or are not part of the solution. So if it was one of these, the points on the line are part of the solution, but if it's one of those, they are not. So now we need to graph it. We're going to start at 7, and we're going to go down 1 and over 2. And again, this is a dashed line. Shade the appropriate part of the graph. The inequality uses the less than symbol, so shade below the boundary line. Check the solution by filling in the table. Is 0, 0 above or below the line? That's below the line. And then if we plug in 0, 0 into the inequality, remember, go back to the original if you're checking, because if you make any mistakes in the calculations, this will help you make sure that you did everything correctly. All right, so 2 times 0 is 0, so we have negative 14, and then negative 0 is just 0. Is negative 14 less than 0? Yes, that is true, which is why that point is in the shaded section. 8, 8. That is above the line. So negative 14 plus 16, is that less than negative 8? Well, that would come out to 2. Is 2 less than negative 8? No, that is false, which is why it is not in the shaded section. It also asks if 6, 4 is part of the solution. 6, 4 is on the line, but it is a dashed line. So it is not part of the solution. And let's look at why. We had this inequality to start with. So if I swap it out with the point here, let's see what we'd end up with. All right, so 2 times 4 is 8, and that would be negative 6. Well, negative 14 plus 8 is negative 6, but negative 6 is not less than negative 6. So it would only be part of the solution if it had the less than or equal to symbol. But because it does not, it is not part of the solution set. Now we are going to graph the inequalities given here. To start off, we need to change them into slope-intercept form. Remember, you have to switch the symbol when you divide by a negative. All right, so we're going to start at positive 3, and then we're going to go up 5 and over 1. So up 5 would put us at 8 and over 1. And then we're going to use a dashed line through here. And it says y is greater than 5x plus 3, so we need to shade above the line. With these very steep lines, it's sometimes a little tricky to figure out which side would be considered above. So let's consider when x is 0. If x was 0, 0, 0 would be below, but 0, 6 would be above. So we're going to shade the side that's above. All right, number 4. We need to move the 10x over, so we'll have 8y is less than negative 10x plus 64. And then we need to divide by 8 on both sides. We did not divide by any negatives, so we do not flip the symbol. We can reduce that to be negative 5 over 4 as our slope, and 64 over 8 is positive 8. Now to start graphing, we're going to go up to 8, and then we'll go down 5 and over 4. So if we were at 8 and we went down 5, we're now at 3, and we're going to go over to 4. Then you can continue that again, to get an idea of how that line continues. And then also you are using a dashed line since there is no equal to symbol under your inequality. And since it's that less than, we're going to shade below. Again, if we were looking at that point 0, 0, 0 would be below, and then 0, 10 would be above. So we want to shade below the line. Moving along, it says write a linear inequality to represent the information or graph given. Elijah can spend at most $8.25 on snacks for a party. Carrots cost $2 per package and grapes cost 75 cents per bag. Write a linear inequality to describe the situation. Let X represent the number of packages of carrots and Y represent the number of bags of grapes. Use the less than or equal to symbol for at most. If you can spend at most $8.25, you can spend $8.25, so we need the equal to, or you can spend less than that. So we have 2x for the carrots plus 0.75y for the grapes, that less than or equal to symbol, and then the total cost, the most that we could spend. Then it says solve the inequality for y. So you can see here they moved that 2x to the other side, then they divided by 0.75, and they have the inequality here. B is a completely separate problem, so the slope will not match part A. Alright, so it says the slope of the line is what? It appears like it starts here at 4, and it looks like there's another place where it crosses in a corner at 4:10. So the slope was going to be the change in y first. So from 4 to 10, that's a change of 6. And then over 4. Or we can reduce that to 3 over 2. The y-intercept of the line is, it appears to me that it goes through that point 4. So the boundary line is y equals, we're going to use mx plus b. So we're going to use that slope first, then the x plus the y-intercept. The boundary line on the graph is dashed, and the shaded region is above the graph, so the symbol will be greater than. No equal to because it's dashed. Now change the equation of the line to the inequality. Complete the linear inequality that represents the relationship shown in the table. Let's plug some of these points in and see if we can identify which way the symbol should go. Y is negative 8, and then we have 2 times negative 3. That gives us negative 6 over here. Which way would the symbol face? Is negative 8 less than or greater than negative 6? Less than, so we're going to fill that piece in. Now we have to figure out the question of, do we need the equal to symbol? So let's continue and see if we can find one where it would be equal. If we put in negative 2 times 2 would give us negative 4, and over here we would have negative 10. That's still less than. Okay, if we did 0, 0, let's see, if I put 0 in y and 0 in the x position, that gives me 0 and 0. So then yes, we do need the equal to piece. Ramona has $18 that she can spend on food for her dog. Dry dog food costs $5.50 per small bag, and wet dog food costs $2 per can. Write a linear inequality that describes how many bags and cans of dog food Ramona can buy. Let's make the dry be X and the wet food be Y. So we know $5.50 per dry and $2 per wet. And it says she has $18 that she can spend. So it should be equal to 18. Can she spend more than 18 or less than 18? If she has 18 to spend, she can spend less than 18 or equal to 18. 7. Describe a real-world problem situation that can be represented by a linear inequality in two variables. Then write an inequality and explain what each part means. Are there any solutions of the solution set that are not solutions to the problem? Let's say you went to the store and you were buying packs of pencils. So it's $2 per pack of pencils and $3 for each notebook. And you can spend at most $25. So then we are going to write the inequality. 2x plus 3y has to be less than or equal to 25. Then it continues on and it says, are there any solutions that are not solutions to the problem? Well, we could put in -10 and -5. That would give us -20 and -15. So that's -35, which is in fact less than 25, but doesn't make sense in the context of the problem to have -10 packs of pencils and -5 notebooks. Well, no. So what it's asking us is, are there solutions to the inequality that don't make sense for the problem? So, yes, there are solutions that don't work for the problem. And that would be any x or y value that's below 0. We wouldn't want negative packs of pencils or negative notebooks, but we could have 0 of each. 8. How can you tell which side of the boundary line should be shaded? If it's y is less than, we would shade below. And if it's y is greater than, we should shade above. This is when it's written in that slope-intercept form. So you could have that mx plus b piece here with various numbers for the slope and for the intercept. Again, that would also include the equal to pieces. 9. How do you graph a linear inequality in two variables? Start by graphing the boundary line. Then you are going to determine if it is dashed or solid. And then you are going to decide if it's shaded above or below.